Good morning, first period. I know you thought you were going to have a day without me, but here is Mr. Bolt again. We've got a few things to talk about. We want to finish some of the mathematics part of the lab we did the other day after the test. And so I want to help you out with that because some of it's pretty complicated. And so if you remember, we threw a ball in the air, and then we were taking a look at how that made a parabola. So we have a graph here. We have our y-axis and our x-axis. And so when we threw the ball, we saw that it made a bit of a parabola shape. The ball went up, and then the ball came down. And then we talked about a lot of the important vocabulary for this. We've got this point up here. That was called the vertex. And then we had these 2 points down here. These were our zeros. And this one over here is also called a 0. And at the vertex, we have a line that comes straight down. That is our axis of symmetry. There we go. That's some of the vocabulary we were looking at. Now, when we timed the ball through the air, we found that it hit the ground after 4 seconds. And it, of course, starts at 0. But we didn't know anything about the height. And so the y-axis, I'm going to cross that out, that's actually going to be our height. So instead of y-axis, we're going to call that the h-axis. And over here, instead of x, this stands for time, so we're going to call that the t-axis for time and height. And so we got all this good vocabulary, but we haven't actually put any numbers to it. And so that's our goal here now, is to put some numbers to it. So what I hope you just watched was a video that shows you how gravity is constant, whether you're dropping a bowling ball or a feather. Gravity is actually constant. That's kind of an important concept. Gravity is constant. So I'm going to write that down. And what that means is we can predict it. We can predict what gravity is going to do. And if we can predict it, we can make an equation for it. And that equation looks a little like this. If you're going to have a function of height, it is going to equal negative 16 t squared plus, this is the weird one, your initial velocity. That's like speed times time. And so that is our function for the height of something that's being thrown in the air. Now it looks a little complicated, but first off, to help make it look a little more accessible, the 16 comes from gravity. That is the fact that gravity is constant. All right, and the v, that is the velocity right when you throw it. The little I down here stands for initial. So at the beginning, what is your velocity? How fast did you throw that ball? That's one of the things we're interested in. We want to know how fast we threw the ball. Now this h of t thing is still throwing us a little bit also. So remember, that just takes the place of y. So this is just like the equation y equals negative 16 t squared plus vi t. And those are multiplying. We're going to use the function notation because it's nice to use the letter h because it stands for height. It will start to mean more and more to us. All right. Well, we've got too many variables, and so we have to get rid of some. So what we're going to do is we're going to plug in something for h, and we're going to plug in something for t. So we're going to put some numbers right here, and on this side. And so we're going to go back to the graph and look at our points. In particular, we're going to pick this point over here. Remember, that is the point 4, 0. After 4 seconds, we were at 0 feet. And so we can plug that in. 4 seconds will, of course, go in for t. And then the height of 0 is going to go in for y. So we'll be left with the equation. Here I'll write the function. H at t is equal to negative 16 t squared plus vi t. And into that we are plugging in 4. So what this equation becomes is negative 16 times 4 squared plus the initial velocity, which we are trying to find, times 4. Now, as we keep working on that, the actual height, we know the actual height is 0. So the left side of the equation can become 0. Equals, let's do some math on the other side. 4 squared is 16, so this will be negative 16 times 16 again, plus, and I'm going to put the 4 on the other side of the v. We usually like the number before the variable. So that will be 4 times the initial velocity. Well, as you can see, now we only have one variable. We can solve this equation. So I'll do that fairly quickly. Hopefully you can follow along. Negative 16 times 16 is negative 256 plus 4 times the initial velocity, and that equals 0. Next, we're going to add 256 to both sides. Add it to the other side. That goes away. We're left with 4 times the initial velocity is equal to 256. Divide both sides by 4. And our initial velocity comes out to be 64 feet every second. That is how fast, I think this was Nelson's time, I believe. That is how fast Nelson threw the ball up in the air, vertically. 64 feet per second. I looked it up, it's about 45 miles an hour was how fast he threw it up. Not a bad throw considering that's only thinking about the vertical, not the horizontal. 64 feet per second up. So we can now finish our formula. So now we have h at t is equal to negative 16 t squared. But now we know the initial velocity, so we can do plus 64 t. All right. So this new equation, so this function models how high the ball is going. Let me resize that so you can see it. All right. It tells us how high the ball is going to go, depending on what time it is. So, what if we were curious, how high is the ball after 1 second? Let's answer that. How high is the ball after 1 second? Well, now that we have our formula, we can simply plug in 1 in for t. Our time is equal to 1. We can find h at 1 second. And we'll plug in 1 to figure out how high the ball is. So we have negative 16. We're plugging in 1 squared plus 64 times 1. Let's see, what does that equal? The left side, remember, stays the same. 1 squared is 1. That's nice and easy. Then we multiply by negative 16. So we will get negative 16 plus 64. And that is how high the ball goes after 1 second, h at 1. Let's see, let's finish that off. Negative 16 plus 64 is 48 feet. So after 1 second of flying through the air, the ball is now 48 feet high. And so if we come over here to our graph again, we can put that point on here. So if we go over 1 second, which would be right here, we would be up to 48 feet. So right here is the point 1, 48 on our parabola. Alright, so that's where it is at 1 second, but oftentimes we want to know the vertex, which in this case is the maximum. How high does the ball actually go at its very tallest? Well, if it landed at 4 seconds, halfway to 4 is at 2. You just divide that by 2. So we need to know how high did the ball go after 2 seconds. So we're going to do the same thing we just did. Let me write down that question that we're doing there. What is the maximum height? And so remember, this is finding the vertex. Alright, so we have to plug in 2 this time. H at 2. Because we know at 2 seconds, that is where our vertex is. That is the axis of symmetry. So we'll have negative 16 times 2 squared plus 64 times 2. So all we're doing is plugging in 2. Now it just becomes a little bit of arithmetic. 2 squared is 4 times negative 16 plus 64 times 2 is 128. The left side doesn't change at all, so I'm just going to leave it alone. 16 times 4 is negative 64 plus 128. All right, one last step here. One more addition to do. And so we know h at 2, I'll bring the left side down, equals negative 64 and 128 is positive 64 feet. So this gives us the point x is 2 and y is 64, or in this case time and height. So let's put that on our graph, and we can finally know how high the ball actually went when Nelson threw it last time. So this point here, it's the wrong one, is the point 2, 64. And that is our vertex, the tallest point on the parabola, the highest the ball ever goes. Happens at 2 seconds. All right, now you guys are going to do this on a worksheet for the other 2 throws that we did that have different times. So most notably, this number right here is going to be different. It's not going to be 4. And so a lot of the math will change, but the steps will stay the same. Good luck.